For this screencast, I'm going to talk about another problem which is quite common in boundary data we are dealing with, and that is where you want to create an area out of a hole in existing boundary data because one of the boundaries is missing. So I'm going to go through three different ways of doing this, which might be appropriate in different situations. So I'm going to start with a real example, which is in the electoral wards of Kenya. So this is a case where we got the data from the IEBC API, which had a series of links to GeoJSON files for each ward, and some of these links were 404, and these roughly correspond to the holes you see in the map here. So I've done some checking, and I've worked out that this region here, which I'm going to zoom in on, this is actually a single ward. Obviously, when you have a hole, you need to check, what the hole should be in the data. But I've done that, so basically all I want to do is create a new polygon out of this hole that exactly matches it and insert it into the existing layer. So as I say, we'll try three different ways of doing it. One thing just to note for a start is that, like many of the cases we're looking at, the boundary data isn't brilliant here. Like you can see, there are these gaps between the edges of the polygons, and the opposite problem with some of them, they overlap as well. So I'm first of all going to make this layer a slightly different color because it's a bit close to, it's a bit close to the color of selected data. Okay. So the first technique I'm going to try is to basically create a convex hull. Well, so the first two methods I'm going to look at both involve creating a larger region on top of this one in a new layer, and then working out the difference between that layer and this one, which should create a polygon which exactly matches that hull. And there are two ways we're going to look at doing that. The first is creating a convex hull of the areas around it, and the second one is hand drawing a region which we know will include it. So to start with the convex hull method, if you go to the select options here, and select feature is the one that just lets you click to select things, so I'm control clicking to select all these areas that surround it. Then in the vector menu and under geometry tool, geoprocessing tools, there is a convex hull option. So if I select that, it'll create a convex region which completely encloses all of the ones that I had selected. So I zoom out a bit, you can see what that looks like, and turning on and off the visibility of that layer, you can see it's definitely includes our polygon. So that's good. So now to work out the difference between the two of them, these are now different layers. We can use another tool from geoprocessing tools, which is, you see it has various operations here that are kind of like set operations, that are, where it depends on whether there is a polygon at a particular point in one layer and the next. So in this case we want to use the difference one, which is like subtracting one set of polygons from another. So the complicated bit here, you can see we've got the input layer and the difference layer is working out which way round they go, because it's an asymmetric operation. So the input layer in this case, this is the one that we are subtracting from. So let's make that the convex hull. And then the existing wards data are all the bits we're taking away. So we basically want to take away the wards that we have and just leave behind the hole, basically. So if I run that, hopefully that will do what we want. Okay, so it looks pretty good. So I'm going to now just hide the convex hull region, and actually just to make this less confusing, I'm going to deselect all these regions in the other layer, so we don't need them anymore. And actually I accidentally turned on editing for this layer earlier, so I'm going to turn that off. So now the difference area, if I turn it on and off, you can see that has various holes in the underlying region. So actually this has done something slightly expected. It's clearly taken notice of which areas I still had selected, and so it was only using them for the difference. So we do have these extra bits around the edge there. But as a small irritation, I don't think it's worth redoing the screencast for. But anyway, so as you see, even if we didn't have these extra large regions here, there would still be extra little polygons from the difference created by the gaps between the layers. So in either case, we'd want to do a little bit of, whoops, that's too far. We'd want to do a little bit of tidying up. To do that, I'm going to turn off the Kenya Awards one because it's obvious, really, which regions we want to get rid of. And to do this, I might do select features by freehand. So here you can just kind of draw a region around. Whoops. And okay, this shows another problem. So in this case, what we can see is that this is actually a single multi-polygon. It's a single feature that was created by the difference operation. And what we really want is for these to be separate polygons, so we can select the ones around the outside separately from this one in the middle. So there is an operation to do that, which is, again, one of these vector operations. This time it's under geometry tools, and it's multi-part to single parts. So if we run that and make sure it's on the right layer, run that on difference. See, now hopefully we can select these bits individually. Yes, that looks good. Okay. So I'll go back to the freehand tool and kind of draw around some of these areas. And just press delete to get rid of them. Oh, it warns me that the layer is not editable. That's annoying. Okay, so hopefully now I can start removing some of these. Yeah. Oh, it says there are no selected features in this layer. That's surprising. Oh, it looks like that was because I had selected. I did actually delete those regions, but they were from the difference layer, not from the single parts layer. So yeah, it's very easy to get confused about which is your active layer when you're doing this kind of thing. So in that case, because in that case the difference layer looked basically identical to the single parts layer, which was the result of splitting it. Okay, so I'm not going to worry about that too much. I might just remove the difference and convex hull layers now to avoid that kind of confusion. So I saw a few more of these regions we can get rid of by hand. So if I zoom in a bit more, so this is kind of just a process of tidying up the data we've generated. Let's see, some more around the edge here. Okay, and now I'm going to zoom in just on this corner here and see what's going on there. So there's kind of a, it looks like this is an artifact from the split at the edge there. So this, again, these are two boundaries meeting here and here, and oops, what we want actually is to just trim off that bit of the region. So I'm going to use the split features operation for this. This basically just allows you to draw a line from one point to another and split the features along that line. So I click with left click to start and end the line, and then right click to say we're completed. That should then allow me to select this feature here. Right, and I can get rid of the other two more easily now. Okay. So zoom out a bit and see if there are any more of these stray areas. Yeah, so there's one down here as well. So I can use the same operation there. Again, that's split features. It's easy to get confused. There are various toolbar things that have little scissors on, but the one you want is split features, which looks like it's cutting between two regions there. So I'm not going to do this terribly precisely. Obviously, I'm going to zoom in and do this by hand, but I'm going to select that and then get rid of that. But yeah, just for example, I'm not being too careful here. So now I would just check in the attribute table whether there are any extra features I haven't noticed. And it looks like, yeah, that's the big one, but then there's one more, which I can't immediately see. So let's zoom to selection to see what that is. Okay, so that's another very small little polygon there. So I'm just going to delete that again with the delete key. Okay. So if I now turn back on, or turn on the visibility of the Kenya wards layer, you should see that this nicely fills in the hole that we had there. And so now to merge that together, you could use the under vector data management tools. There's merge vector layers, which is what I'd use to put that into the single layer again. Okay, so that's the first way of creating a hole out of creating polygons out of the holes in existing boundary data. So I think that's probably most useful where you have quite a lot of these holes, and ideally where there aren't these kind of awkward gaps between adjacent polygons, because then you can create a lot of these holes in one go, and effectively it's quite a simple operation. One way which might have been better in this situation, which I'll talk about now. So I'm just going to remove that layer we just created somewhat painstakingly to show how we do it another way. So a lot of the work we had to do there was just because the convex hull we created around it wasn't a particularly precise, didn't precisely fit the polygon we were creating there. So another way of doing this would be just to hand draw something which we are pretty sure covers that, but doesn't include too much kind of extraneous data. So I'm going to do that by creating a new layer. So when you create it, we're going to need a new shapefile layer, and it's going to be of type polygon because we want to draw a polygon. Don't worry about what fields we want in it for the moment. If I click OK there, yeah, that pops up, although annoyingly popped under a save dialog. So you have to save the layer before you can work on it. So you'd say covering. Let's call that. So once I've done that, it's made this new layer called covering for me. And in order to create a new polygon in that layer, I need to first toggle on editing, and then go to this add feature option. And here, I'm going to zoom in a bit to get these corners right. So one of the advantages of doing this is that you can be you can deal at this stage with where you want the slices of the edge to be. Let me see. So I don't have to be too precise here. I'm just going to take more care at the points we saw previously, where we're meeting the kind of cracks at the edge of other polygons. I'm actually just going to turn off the OpenStreetMap layer, actually, because that's making it slower to zoom. Okay, and then right-click to finish that. I don't particularly mind what ID it has in this case. So effectively that's doing something very similar to the convex hull, except in intent. So we can then do the same steps after that, where we go to geoprocessing tools and difference. So the input layer is the one we just created, covering, and the difference layer is the Kenya wards. So if we run that, I'll now remove the covering layer, just so it doesn't get confusing. And now you can see we have a nice polygon filling that hole there. And I'll just check the attribute table to see if we have any extraneous... no, we don't have any extra little polygons created there. So I think that looks pretty good. I mean, maybe one should check more carefully around it. So yeah, there's like the odd crack around the edge here, which we could have dealt with by creating the covering layer more carefully there, or we could again use split feature to take off those bits now as well. But basically for a single polygon, that would be quite a bit quicker, I think. Okay, so I said there was a third way of doing this. So again, I'm going to go back to the start, remove the difference layer. Yeah, what we just created. So the other way is something I've talked about in another video, which is to use the enable tracing option when you're creating a new polygon. So this means that you can essentially create a polygon when you're adding a feature by following around the borders of other features, which is a very powerful way of quickly creating new polygon data. So I'm going to start that by doing the same thing as before, create a new layer, new shapefile layer, make sure it's a polygon, and then again, unhelpfully, it creates that new save dialog underneath. So I'm going to call this one, let's see, direct, because we're directly creating it. Of course, it doesn't really matter what this name is, it's going to be a kind of throwaway layer. Now, I'm going to toggle that layer into editing mode. I need to enable snapping, so that it does actually match the line. You can start and end on points on the line easily. Snap to vertexes is all we'll need. The tolerance, I normally set this to within 20 pixels, which seems about right for me. And then the layer selection, we want to be able to snap to lines in any visible layer. So do it like that. Okay. Now we need to turn on this option here with the magnet and enable tracing, and click add feature. So as you can see, if you go near these lines, the little or near the vertices on these lines, the little pink cross appears, which means that you've snapped the line. So I can click there, and then as we move along, it will trace along the edges of these lines. So I don't want to go that far, because then that would include this little sliver down the edge, because it's following right around the edge of these polygons. So I'm going to zoom in a bit and make the first point this vertex here, jump to across to, let me see, actually this is slightly annoying because it's when it snaps directly to that, it's immediately jumping across the hole that we're trying to avoid. So what would be a way of dealing with that? I think what I want to do is go to a point midway between the two of them. So I might just reduce the snapping depth, because I can't even click in between them at the moment, because it's snapping too precisely. So let's try that. Click on a point there, turn back up the snapping. So there might well be a smarter way of doing this, but this is not a problem we very often have. So let me see if I go around to here. That line is just going back to the beginning of the polygon we're drawing, so as we carry on around, that shouldn't be a problem. So go around to here. And again, I'm going to do a slightly hacky, placing a new freehand point in the middle to make sure it doesn't follow around the gap there. Same thing here. Yeah, so this means basically you don't have to worry very much about any of the points as you're going along, except those where there's this kind of crack into the next polygons there. It's not actually snapping, there's no vertex there to snap to, so I'm just going to create a point freehand here. Oh, actually I could turn on snapping to segment there. That might have been a better idea, but this will do. As I say, the precision of the boundary data here is not such that this is going to be the worst bit of boundary data by any means. Okay, so just one more bit to be careful of down here. So this is the kind of place where you might want to look at the OpenStreetMap data underneath just to see if there's any kind of guidance about where the lines might lie underneath. So there are kind of some roads under there, but I don't think they're closely aligned enough that it gives us a good guide about where these points should be. So if I go back to this and add feature, it keeps the tool active in a way so you can switch about and try different things like that as you go along. So I think we can go right back to the beginning now and right click to finish that. Don't need to worry about an ID there. Okay, so there we are, and we have a nice new polygon. Let me save that, toggle it out of editing mode. Which again, if we turn it on and off, nicely fills the hole left by the other polygons. Okay, so that's the third way of doing that, and you know, in each different case, one of these methods might be quicker than the rest of them, but hopefully that gives you a good idea on how you can go about filling in gaps in boundary data that come up in situations like this. So I hope that's been somewhat useful.